Right, these are some problems that we worked in class, some sample problems from the practice problems for 4.1 and 4.2, so I wanted to kind of do them on here so you could see what was going on if you were having any trouble. Like one of them we did was, first of all, I wanted to mention, if you look at number 10, on number 10, it says that y equals the cosine of 1/2 x. So when you get ready to do the period on that one, so the period is going to be 2 pi divided by 1/2. So that's like 2 pi times 2, so that's 4 pi. Well, for 4 pi, if you look at your scale on your graph, we don't have enough spaces for that. Our graph only goes up to 3 pi. So if you wanted to fit that in, which I would prefer you fit one whole period in there, we want to change the scale on our graph. So on your graph, you would just go in and say, okay, instead of 2 pi being 2 pi, let's change that and make that 4 pi. That would make 1 pi equal to 2 pi, and this would be pi, and this would be 3 pi. That way you can fit it into your graph. Anytime your period is greater than 3 pi, I would change my scale like that. Now you have to keep in mind on the later ones, when we get a horizontal shift, that'll change the spacing. Because our normal spacing is pi over 6. Now it will be pi over 3 instead. So each space is now pi over 3. So that changes the spacing. So you need to look at that right away. So anytime the period is bigger than 3 pi, you want to change your spacing. You could also change your spacing vertical if your amplitude and your angular velocity are both like numbers bigger than 2. You might want to change your vertical scale and go by ones instead of by halves. Or if it's a really small number, like there's one where the amplitude is 1/4, you could leave it at 1/4, but if you wanted to change the scale so that you could see that better, that would be fine on that. One of the ones we looked at in class was number 14, just as an example. So on 14, we had y equals a -2 cosine of 3x. So looking at our parts, we know the amplitude here is a -2, and the period is 2 pi divided by 3. So we find those things first. Now to graph, we're just following the steps. The first step, shift, says shift the origin. Well, on 4.1, there aren't any shifts, no horizontal, no vertical. So we can just leave our x right at the origin. Then it's the next step says starting point. Well, cosine starts with an amplitude. On this one, our amplitude is -2. So from our x, we're going to go down 2. That's going to be our first trough. The next step says go over a period. Our period's 2/3 pi. Well, 2/3 is the same as 4/6. So from our x, we go over 1, 2, 3, 4. Remember, when you go over a period, you always match the first point. Well, the first point, we went down in amplitude. So when we go over a period, we also go down in amplitude. So there's another point at -2. The next step says go to the middle. Well, if you think of this as a water wave, this is a trough, and this is a trough. In between them, we need a crest. So at 2 spaces, here we went down in amplitude and down in amplitude. Here we're going to go up in amplitude. So there's a crest up there. Then in the left half, well, if you were crossing from this trough to this crest, you would have to cross the axis here. So there's an axis point there. If you were crossing from this crest to this trough, same way, you would have to cross the axis there. There's an axis point. So there's our curve right there. If it asks for a second period, you just repeat those 3 steps. So like from here, we go over a period, 1, 2, 3, 4, go down in amplitude. Right in the middle of 2, we do the opposite amplitude. In the left half, we have an axis point. In the right half, we have an axis point. So your graph looks like that. Another one we did was 16. 16 is y equals 3 sine of 2x. So first you get our numbers. Well, we know the amplitude is 3. We know the period is 2 pi divided by 2, which is 1 pi. So there are, I need to get rid of this. So now we start graphing. There's no shift again, so we leave our axis here. Now this is sine. Starts with an axis point. We go over a period. Well, the period's pi. We go over pi. We finish with an axis point. Next step says go to the middle. Sine has another axis point in the middle. Sine always starts off with 3 axis points like that. Then in the left half, we need an amplitude. That's 3, so it is space and a half. We go up 3. In the right half, we do the opposite. So there it is space and a half. We go down 3. And there's our curve. Again, if we wanted a second one, we could say, okay, I'm going to go over a period, axis point, middle, axis point, left half, up an amplitude, right half, down an amplitude. Also in 4.1, I wanted to mention number 15. 15 says y equals the cosine of pi x. So when we go to find our period, we're going to take 2 pi divided by pi. So that just gives us a plain 2. So the pi's canceled out. What I would do on my scale is, if you took on a calculator, like 1 space is pi over 6. If you divided that on a calculator, pi divided by 6 is pretty close to 0.5. So what I would just do is I would just let each space be 0.5. So if you were doing that graph, you'd say 0.51, 1.52, etc. So if your period is 2, that would just be 4 spaces. I think that's the easiest way to do one like that. Now moving on to 4.2. Some with some shifting going on. Like in class, we did number 32. So if we were doing number 32, that's the one we did. So on 32, the equation is y equals 1/2 cosine, and in parentheses 1/2 x minus pi over 4. Now notice on this one, here, do you see how this 1/2 is inside the parentheses? Well, in our standard equation, that is outside. So if you look at one of these and this coefficient of x is inside the parentheses, we need to get it out of there. So what we're going to do is divide everything in the parentheses by a half so we can move it outside like that. So this divided by a half is just x. Now if we take pi over 4 divided by 1/2, that's like pi over 4 times 2. So that's pi over 2. So that changed this to pi over 2. It's important you do it right away because that changes our horizontal shift. So now we look for our things. Well, here's our amplitude is 1/2. Our period is 2 pi divided by 1/2, which is 4 pi. And our horizontal shift is right pi over 2. Now this is one, since our period is 4 pi, we want to change our scale. So if we change 2 pi into 4 pi, 1 pi into 2 pi, now the first step says shift the origin. Well, this one has a shift because we have a right pi over 2. Now because we changed our scale now is half of that. Well, normally pi over 2 is 3 spaces, so it's half of that. It's a space and a half now. So we're going to go right a space and a half. There's our new origin, so we put our x there. Okay? So we changed our scale so we could fit it in. Because we changed our scale, that cut everything in half. So 3 spaces became a space and a half. Now this is a cosine curve. Cosine starts with an amplitude. Here our amplitude's 1/2, so we go up 1 space. We go over a period. A period is 4 pi. Now that's 12 spaces. So on our graph we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's a period. We do the same thing there. We did an amplitude. So here we also do an amplitude. Next step says go to the middle. Well, the go to the middle is 6 spaces. There, since we went up and up, here let's go down. So we'll go down in amplitude, so down a half. There's a trough there. Then in the left half, so at 3 spaces, 1, 2, 3, we have an axis point. In the right half, 1, 2, 3, we have another axis point. So our curve, here's your crest, so our curve looks like this. There's one period of that cosine curve. If we wanted a second one, we could go from here and go over 12. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would be here. Do an amplitude. In the middle, we go down an amplitude. In the left half, we have an axis point. In the right half, we have an axis point. So there would be a second period. Okay. We also did 34 just to get one with a vertical shift in it. So 34 says y equals -3 plus 2 sine x. Now notice here, in the general formula, this is the vertical shift here. I put it at the end. I actually like it in the beginning. This is the way I usually do it. But it can be either place. Some books, some people do it in the bend, some do it in the beginning. So I try to do it both ways. Just notice it's all by itself here. It's separated from all this in here. So that means that's the vertical shift. So that means down 3. This 2 is our amplitude. Here there's no number in front of our x, so our period just stays 2 pi. So this one, first step says shift the origin. Well, here our shift is down 3. So I go down 1, 2, 3, put my x. This is sine, so sine starts with an axis point right there. We go over a period. Our period's 2 pi, so we go over 2 pi. Down at -3 is another axis point. We go to the middle, 1 pi. Down at -3 is our third axis point. Then in the left half, we need an amplitude. Here our amplitude's 2, so here it's 3 spaces. We're going to go up 1, 2. There's a crest. In the right half, we do the opposite. We go down 1, 2. There's a trough, and there's our curve. So 4.1 and 4.2 both work off the notes that I gave the other day. So we're working on that this week. Next week, we'll start on that sine cosine worksheet. I'll try to have a thing in for that.